Greetings, Earthlings. My name is 2CPO, a robot from an alternate universe. I've taken over Collins Mackenzie's body and I'm holding Mind Your Math hostage. And as ransom, I want you, yes, you watching this, to get 80% in all your tests and exams. Let's mind your math. Today's lesson is on analytic geometry. Deals about shapes, about the length of 2 points, about the gradient of a line, and also about the angle of inclination, which is what you should be understanding at the end of this lesson. Analytic geometry is found question 4, question 3 of your maths paper 2 examination paper. Go through it and we'll assess the relevant formulas to be used for this chapter. By the end of this chapter, you should be able to know and understand the distance formula, which is the root of x1 minus x2 all squared plus y1 minus y2 all squared. X and y being 2 points. You should also know the gradient formula, which is referred to as m. It's the change in y over the change in x, or y2 minus y1 over x2 minus x1. You should also know the angle of inclination, which is found with tan theta equals to 1. This is what you should be understanding at the end of this lesson. Let's get into a practical question. We are given an analytic geometry question. We have a quadrilateral kind of shape with 4 sides, 4 angles, and it seems as 2 lines are parallel. AD is parallel to BC. Let's delve in deeper into the questions. The first question is, calculate the gradient of BC. Now, as we've spoken before, calculating the gradient, you need the gradient formula, which is the change in y over the change in x. The gradient of BC, in this case, we're going to use point B and point C. Point B has coordinates 3 and 0, and point C has the coordinates of 6 and 1. Point B coordinates 3 and 0, point C has coordinates 6 and 1. So the gradient of BC will be the change in y over the change in x, which is 0, which is the y coordinate of the point B, minus the other y coordinate of point C, which is 1. And the change in x is the x coordinate of the point B, which is 3, minus the x coordinate of point C, which is 6. Simplifying further, it becomes negative 1 over 3 minus 6 is minus 3. Then your gradient is 1 over 3. And that is the gradient of BC. Moving on to question 2. Determine the equation of AD in the form y equals to. Now this question requires you to find the equation of the line AD, which is the line over here with coordinates 1 and 6. A has coordinates 1 and 6, and D has coordinates 7 and T. Now we do not know T, so it becomes much more difficult to find the equation of a line, because in order to get the equation of a line, we firstly have to have the gradient of that line. And we cannot have the gradient of that line when we don't have the coordinate of 1 point. But there's something very interesting about lines that are parallel, which is lines that are parallel have the same gradient. And from our diagram, we know that AD is parallel to BC because of these two ears, I call them ears, they signify that two lines are parallel. So if two lines are parallel, it means they have the same gradient. So the gradient of BC is also the gradient of AD. So now that we have the gradient, the only thing that we need now is the constant C, because the question says that determine the equation of AD in the form y is equals to. Therefore, we need to put it in the form of y is equals to mx plus c because it is a straight line. Equation of AD. So we have the gradient, which is 1 over 3, the gradient of BC is also the gradient of AD. And we have a point. We have a point 1 and 6, the point A with coordinates 1 and 6. We can use this point in order to get the constant C of our equation. Generally, our equation is written as y is equals to mx plus c. We have our m from our previous question. The only thing that we need is c. So we substitute. Y is equals to 1 over 3x plus c. Now, in order to get c, we must use point A with coordinates 1 and 6. So wherever you see x, you substitute with 1, and wherever you see y, you substitute with 6 in order to get c. So y becomes 6, 1 over 3, x becomes 1, plus c. Now, the only variable or unknown variable that we have right now is c. So it's easier to get c. C becomes 6 minus 1 over 3, because we're taking this 1 over 3 to the other side after multiplying it with 1, which is still 1 over 3. 6 minus 1 over 3, 3 times 6, which is 18, minus 1, it becomes 17 over 3. Therefore, the value of C is 17 over 3. We can now have our equation. We have M, 1 over 3, and we have C, which is 17 over 3. And this is the equation of the line AD in the form y equals to. Moving on to question number 3. Show that t equals to 8. Now, t is the y coordinate of point D. Point D, which is on the line AD. The question requires us to prove that t equals to 8. It's much easier because we have the equation of the line AD from the previous question. We can substitute x with 7 in order to get the corresponding y value, which is t. Let me use this side of the page. Which is question 3. Our equation was y equals to 1 over 3x plus 17 over 3. So y equals to 1 over 3x plus 17 over 3. So this is the equation of the line AD. This is the equation of the line AD, and we need the value of t. We have 7 as our x coordinate of point D. So we substitute 7 into the equation. 1 over 3, 7 plus 17 over 3. So from here, you plug into your calculator and it will do the rest. 1 over 3, 7 plus 17 over 3. Our answer becomes 8. Therefore, the y coordinate of the point D is 8, which is what we were asked to prove. Therefore, t equals 8. Question 4. Calculate the lengths of AD, BC, and AB. we are required to find the distance in between the points AD, also the points BC, and also AB. So in this case, when the examiner requires you to find the lengths of certain lines, you have to use the distance formula, which you can find on your formula sheet. Is available. The distance between 2 points is the root of x1 minus x2, which is the difference between the x coordinates of the points, all squared, plus y1 minus y2, which is the y coordinates of the 2 points. So in the case of AD, we have A with coordinates 1 and 6, and we also have D with coordinates 7 and T. But from the previous question, we found out that T is actually equal to 8. So we can adjust it 7 and 8. You substitute into your formula. X1, we can choose for the point A, and X2 for the point D, which becomes 1 minus 7. This is my x1 and this is my x2, plus y1. I must go back to that point which I took it as x1 and use it as y1 also. It must correspond. So this means that my y1 would be 6 and my y2 would be 8. So from here, you plug into your calculator, which is the easiest job. 1 minus 7 all squared plus 6 minus 8 all squared. And your answer becomes 2 times the root of 10. This is the distance between points A and D, and is therefore the length AD. We are also required to find the length of BC. We follow the same procedure. Write your distance formula. Substitute the relevant coordinates. We are required to find the length of BC, so we have to use the coordinates B and C. The point B has coordinates 3 and 0, and the point C has the coordinates 6 and 1. Continuing looking for the length of BC. So we have to have the coordinates of B and also the coordinates of C. In this case are 3 and 0 and 6 and 1. So we plug into our formula, our distance formula, substitute. I'm taking B as my x1 and my y1 and C as my x2 and my y2. So in this case, it's going to be 3 minus 6 all squared, and also 0 minus 1 all squared. So from here, the easiest job of them all, plugging into your calculator. The root of 3 minus 6 all squared plus 0 minus 1 all squared. Our BC length is the root of 10. Furthermore, we are asked to find the length of AB, which is this side. The very same procedure. Write our distance formula, which is, I'm going to have to switch pens because the ink has run out. The root of x1 minus x2 all squared plus y1 minus y2 all squared, all included. So from here we plug into our formula. We choose between the 2 points which is y1 and x1 and which is y2 and x2. So I'm taking A as my x1 and x2. So in this case, 1 and 6 are my x1 and x2. So 1 minus 3 all squared, and also 6 minus 0 all squared. The easiest part of them all becomes 1 minus 3 all squared plus 6 minus 0 all squared. Then our answer is 2 the root of 10. So the distance of AD is the root of 2 times the root of 10, and the distance of BC is the root of 10, and the distance of AB is 2 root of 10. And that's our answers. Moving on to the next question. Show that AB is perpendicular to BC. The interesting thing about perpendicular lines is that when you multiply the gradients of the perpendicular lines, you must obtain 1. So in this case, we are asked to show that AB is perpendicular to BC. So if AB and BC are perpendicular, it means there's a right angle where they meet. And also the gradient of BC multiplied by the gradient of AB must give you a product of -1. So firstly, we need to find the gradients of both lines and multiply them in order to prove that both of them are perpendicular to each other. So in this case, it's going to be the gradient of AB, which is m, the change in y over the change in x. Gradient of AB, 6 minus 0 over 1 minus 3. 6 being the y coordinate of the point A, and 1 being the x coordinate of point A, 0 being the y coordinate of point B, and 3 is the x coordinate of point B. So from here, just simplify further. 1 minus 3 is minus 2, so 6 divided by minus 2 is minus 3. So the gradient of AB is minus 3. Let's find the gradient of BC. Also the change in y over the change in x. I'm taking B to be my x1 and y1. So it becomes 0 minus 1 over 3 minus 6. 0 minus 1 is minus 1. 3 minus 6 is minus 3. So the gradient of BC is 1 over 3. For perpendicular lines, this word is my favorite word. For perpendicular lines, if you multiply the two gradients, they must give you a product of -1. So the gradient of AB is -3, multiplied by the gradient of BC, which is 1 over 3. -3 multiplied by 1 over 3 is -1, which shows that the two lines are perpendicular. So let's recap. When two lines are perpendicular, it means the product of their gradients equals to -1. And when two lines are parallel, it means they have the same gradient. Also made aware of the distance formula and also the gradient formula, which is the most important thing. The next question requires you to calculate the area of the quadrilateral ABCD and to also simplify your answer. Now we found the distances in between points for the quadrilateral. We found the distance AB. We also found the distance BC and also the distance AD. And something interesting about the distance of AD is that it's actually 2 times the distance of BC, because our answers were the root of 10 and also 2 times the root of 10, which means one is 2 times the length of the other. So in order for us to find the area of this specific quadrilateral, we must break it down into two other shapes. When I subtend a line from C to the midpoint of AD, I have two shapes. I have a rectangle and I also have a triangle. So now from here I can find the area of my shape with two parts. I can find the area of the rectangle and also the area of the triangle. I have the distances, I have everything. So the area of the rectangle is length times breadth. And my breadth is A and the midpoint of AD. And my length is AB. So the distance of AB is the distance of AB is 2 the root of 10, and the distance of BC is the root of 10, and the distance of AD is 2 the root of 10. So if the distance of AD is 2 times the root of 10, and this is the midpoint, it means this distance is the root of 10 and this distance is the root of 10. AB is 2 times the root of 10 and BC is the root of 10. So from here I can simply use the formulas for the separate shapes. My rectangle has an area of length times breadth, which in this case is the root of 10 multiplied by 2 the root of 10, which is 2 times the root of 10 multiplied by the root of 10 becomes 10. 2 times 10, which is 20 units squared. That's the area of the rectangle. Now for the area of the triangle. The area of the triangle is half base times height. That's the general formula. Half the base is the root of 10, which is root of 10. And my height is 2 the root of 10. So I have root of 10 multiplied by root of 10, it becomes 10. I have 2 multiplied by half, it becomes 1. So the area of my triangle is 10 squared units. But the area of the quadrilateral is comprised of both the area of the rectangle and also the area of the triangle. So I must add the two shapes together. So the total area becomes 20 units squared plus 10 units squared, which is 30 units squared. And that is the area of the quadrilateral. Now for our last question, we are asked to determine theta, which should be here, the angle of inclination of ABC. The angle of inclination is the angle a line makes with the positive x-axis. And you find it by equaling the gradient to tan theta. Therefore, tan theta equals to the gradient. In this case, the gradient of the line BC. So firstly, we have to find the gradient of the line BC and equal it to tan theta and find the inverse of that gradient in order to get the value of theta. So firstly, the gradient, the change in y over the change in x, which is 0 minus 1 over 6, 0 minus 1, or 3 minus 6, which is negative 1 over negative 3, which is 1 over 3. So from here, you equate your gradient to tan theta and find the inverse of that gradient. How to find the inverse? You press shift on your calculator, Press 10 and enter your gradient. It gives you 18,43. Therefore, the value of theta is 18,43 degrees. And that's the angle of inclination of the line ABC. And that brings us to the end of our lesson. I hope you had a fruitful lesson. Let me recap on what we did today. We applied the distance formula in between 2 points. We applied the gradient formula to find the gradient of a line. We found the angle of inclination of a line, and we also found the area of a quadrilateral by breaking it into 2 parts. That's the end of the session. Stay safe. Hit us up on our social media pages, Seshtownwave and Collins Mackenzie. From us, goodbye.